What happens when you enter an ecosystem that shouldn't exist? Imagine entering a place on Earth that was never meant to exist in any intuitive sense of the word. A world with no sunlight, no plants, no visible ecosystems, and no surface energy flow. A realm buried beneath oceans, ice sheets, continental crust, and ocean floor sediments, where darkness is not temporary but absolute. Pressure is immense, temperatures can be extreme, oxygen is absent, and yet something is alive there. Not in theory, not as speculation, but as measurable, functioning biology. This is the deep biosphere, one of the most mysterious and least explored hidden ecosystems on Earth. For most of human history, life was assumed to depend on sunlight. The model seemed unbreakable. Sunlight feeds plants, plants sustain animals, and ecosystems are built on that foundation. Remove the sun, and the system collapses. But deep underground, inside rock fractures, habitats, and microscopic pores of stone, scientists discovered something that shattered that assumption: completely subsurface life. Entire microbial communities exist kilometers beneath the surface, completely cut off from sunlight, oxygen, and surface nutrients, yet still metabolizing, adapting, and surviving. These organisms are known as extremophiles, life forms specialized for survival in conditions once thought impossible. They endure high-pressure conditions that crush ordinary cells, high-temperature survival beyond boiling thresholds, radiation resistance that protects their genetic material, and oxygen-free environments where most known life would fail instantly. Their existence is not just survival, it is adaptation at the deepest biological level, driven by metabolic adaptation that rewrites how life can function. With no sunlight available, these ecosystems depend on entirely different energy sources. Instead of photosynthesis, they rely on chemosynthesis, extracting energy directly from chemical reactions. Hydrogen sulfide metabolism, methane utilization, iron-based metabolism, and hydrogen gas production through rock-water reactions form the foundation of this hidden world. In many regions, processes like serpentinization generate hydrogen as water interacts with deep rock formations. Even radioactive decay deep within Earth contributes to energy production. Here, life is powered not by the sun, but by the planet itself. This creates what can only be described as a geothermal energy ecosystem, where geological processes continuously fuel biological systems. Rock chemistry becomes life support. Minerals act as energy carriers. Earth itself becomes a living engine, sustaining organisms in total darkness. But what truly changes our understanding of life is how it behaves in time. Deep biosphere organisms operate on ultra-slow life cycles, where reproduction may take centuries. Entire populations divide only once every 100 years or more. These are systems governed by geological timescales, not biological urgency. Life here is reduced to its bare minimum: slow metabolism, minimal energy consumption, and long-term survival strategies. This phenomenon is part of what scientists call deep time biology. In these environments, life exists in a near-suspended state, maintaining only the energy required for cellular repair and survival. Evolution does not disappear. It simply slows down to a pace almost invisible to human observation. This is evolutionary stagnation mixed with deep adaptation, where change happens so slowly it becomes almost timeless. Many of these microbial communities have remained isolated for millions of years. This evolutionary isolation has preserved ancient microorganisms that function as living fossils. Genetic sequencing reveals unknown branches of life, entirely new metabolic pathways, and biochemical systems that do not match anything seen on the surface. These findings suggest that underground evolution may have followed an entirely separate trajectory from surface life, and this leads to one of the most profound scientific questions ever asked: the origin of life. Early Earth was hostile, intense radiation, volcanic activity, unstable oceans, and a lack of oxygen. But deep beneath the surface, protected environments like hydrothermal vents and subsurface rock systems may have offered stability and chemical richness. This supports the subsurface origin hypothesis, the idea that life may have first emerged underground in the Earth's crust cradle before ever appearing on the surface. If this is true, then the deep biosphere is not a side ecosystem, it is the foundation of life itself, a living archive of pre-surface evolution, preserving biological systems that may date back billions of years, a hidden record of Earth's earliest biological history. But the implications extend far beyond our planet. If life can exist in total darkness, powered only by chemistry, then similar ecosystems may exist elsewhere in the solar system. Subsurface oceans beneath icy moons like Europa and Enceladus, or hidden water reservoirs beneath Mars, may contain conditions almost identical to Earth's deep biosphere. This transforms astrobiology, shifting the search for life from surface planets to subsurface habitability zones, where chemical energy replaces sunlight as the driver of biology. Even on Earth, we have only explored a fraction of this hidden world. Deep drilling projects reach only limited depths. Ocean sampling captures only fragments of it. The vast majority of the deep biosphere remains unexplored, unmeasured, and unknown. It may contain entire ecosystems with unfamiliar biochemistry, unknown metabolic pathways, and forms of life that do not fit current biological classification. And perhaps the most important realization is philosophical. Life is not fragile in the way we once believed. It is not limited to ideal environments or surface conditions. It is resilient, adaptable, and capable of persisting in places that should not support it at all. Life appears not as a rare accident, but as a persistent outcome of chemistry, energy, and time. So, when you enter an ecosystem that shouldn't exist, you are not just discovering strange organisms in the dark, you are witnessing a hidden universe beneath Earth, vast, ancient, and alive. A world that challenges everything we know about biology, time, and existence itself. And if you found this journey into the deep biosphere fascinating, do us a small favor: like, share, and subscribe. It helps bring more of these hidden worlds and deep science stories to you.